Me when I get to homework.
Okay, guys, well, let's try and remember what we were doing yesterday.
I figured it out. Hang on.
So I asked you guys while I was getting things set up here to try D, which is cosine of 240 degrees. And to see if you can come up with an answer. I mean, it's degrees. At least I'm asking you to start on a degree one, right? I didn't ask you to attempt radians. So there's confidence here, I hope, with degrees.
I was very confident. I think I got it right.
That's good. Okay, so thoughts on where to start on cosine of 240 degrees?
360 minus 240. Oh, but I did that after. That makes me sad. I think I messed up.
Okay, so first of all, good news, 240 is just a regular typical angle, right? It's between 0 and 360. So if I visualize, and again, before I put the unit circle up, if I visualize 240, it's going to be past where and before where? Past 180, before 270. Past 180, before 270 puts us down in quadrant 3. Okay, so now, so we know quadrant 3. I'm going out of order on my steps here, but to me it's easier to figure out the quadrant. What's the actual reference angle we're going to use here? How are we going to figure that out? Yeah, 240 is close to 180, closer to 180 than it is 360. So we're going to do 240 minus 180 to see how far 240 is from the x-axis, right? So if I do 240 minus 180, what is 240 minus 180? 60. So then we're going to be saying, okay, what is the cosine of 60 degrees in quadrant 3? That's what you're asking yourself. What is the cosine of 60 degrees in quadrant 3? So, what is cosine of 60 according to your chart? 1/2? And then, what do you know about cosine in quadrant 3? All students take, so that's the tangent quadrant, which does make it negative. So we have an answer of negative 1/2. The radian ones?
Yeah, the radian ones.
Okay, and what I'm going to keep telling you guys, you have to keep trying on the radians. You have to keep trying to work in radians. Now, I'm not saying you can't check yourself in degrees, but I don't always want you switching over to degrees, okay? It's a good backup plan, but there are times where you can't really switch to degrees, which is why I want you trying the radians. Okay, so E, cotangent of 19 pi over 6. Well, all I can think about 19 pi over 6 is it's big, right? It's more than 2 pi, which, okay, so for reference sake, what is 2 pi here? We're talking, yeah, if we have 19 pi over 6, and we want to talk about 2 pi, well, we want 2 pi in terms of sixth, right? So 2 pi over 1, how do we get denominator of 6? We're going to multiply by 6, and so this is 12 pi over 6, right? So what do we do with 19 pi over 6? We're going to subtract. I just wrote something on the board briefly. All I just wrote on the, I was just showing getting 2 pi to become 12 pi over 6. Yeah, it was just showing getting a common denominator, that if we're talking about 19 pi over 6, and then if I want to talk about, okay, what is 2 pi in terms of sixth? And so how do I get 1 to become 6? Multiply by 6. So then 2 pi times 6 is going to be 12 pi. So the fact when I talk about 2 pi in terms of my denominator of 6, I'm talking about 12 pi over 6. Does that clear up what I spaced on the board? Uh-huh. Uh-huh. Okay. Okay, so if we look at this then, I'm going to try and put it in right here. 19 pi over 6 minus 12 pi over 6. Where does that put me? Yeah, that subtracts to be 7 pi over 6. Now, 7 pi over 6 is more workable, right? And this is where I'm thinking, let me do this on here instead. Okay. Because I tend to forget to move my board back and forth. This is where I'm thinking, okay, over here we've got 2 pi, over here we've got 1 pi, right? So, I'm still not on the screen, dang it. 2 pi is 12 pi over 6. We just talked about that, right? What is 1 pi in terms of sixth? That's 6 pi over 6. So, if our fraction is 7 pi over 6, what do I know about 7 pi over 6? It's going to be just past 6 pi over 6, right? So, this right here, I know it's the idea is that 7 pi over 6 is in quadrant 3. 7 pi over 6 was because I did 19 pi over 6 minus 12 pi over 6. Because I was subtracting 2 pi. And I'm off the screen there a little bit. No, I just zoomed in is what it is. Okay, so 7 pi over 6. It's a little bit past 6 pi over 6. So I need a reference angle that is one of those three. I say 30, 45, or 60, right? Which keep in mind, those are pi over 6, pi over 4, or pi over 3. Well, what happens is if 7 pi over 6 is just a little bit past 6 pi over 6, subtract them, right? So 7 pi over 6 minus 6 pi over 6, which is what? Pi over 6.
Is it always going to end up being pi over something? That's what happened last time.
It's always going to have to, what we're doing right now, it has to end up one of those three angles.
So it has to just be 1 pi every time.
1 pi over something?
Yeah.
Yes. Sorry, I can't agree to the comment. It has to be 1 pi. I was like,
Yeah, I meant to say
not what I'm thinking you're meaning there. But yes, it's always going to be the way these are working. It's always going to come out to be pi over 6, pi over 4, or pi over 3 because it's one of our three from the chart. Okay. So now this means that we are doing the cotangent of pi over 6. And this is in quadrant what? 3. I really need to set this up better. Okay, so it's in quadrant 3, cotangent of pi over 6, which, what do we know about cotangent? It's the reciprocal of tangent, yes? So when I look at my chart, you can either look at the big chart or we're going to do the reciprocal of tangent of pi over 6. So do you have your chart beside you? Can you flip to it? What is the tangent of pi over 6? Tangent, pi over 6. What's the tangent of pi over 6? Square root of 3 over 3. So this is going to be square root of 3 over 3. What about quadrant 3? What do we know about Time out. Okay. I'm making the mistakes you guys are going to make, right? I'm showing you what not to do. Please don't follow my lead here. Okay. Backtrack that in case you're confused about why I'm claiming to be wrong here. It was supposed to be cotangent of pi over 6. I asked what is the tangent of pi over 6 to get us going, and then what I should have done is flip it instead of writing it down, yes? Or just go to the cotangent part of your chart, I guess. I'm just going with, eventually, you're probably not going to have cotangent just flat out memorized. You're going to have tangent memorized. And so, here was tangent of pi over 6, right? Square root of 3 over 3, or 1 over square root of 3. What's the reciprocal of that since we need cotangent? Square root of 3. Is that a positive or a negative square root of 3? We already talked about being down in quadrant 3. All students take. Stands for tangent, positive, and so this is a positive square root of 3. Did I make any sense with my radians there? I know some of you still don't like them, but again, don't zone out on me. Tune me in there so you know what you're doing. And I'll keep pushing them at you. So, you won't like me for it in this chapter, but. Okay. I'm ready for F when you're ready for F. Everyone's like, degrees, yes, got it. Okay, well, so it's cosecant of 495 degrees. I see 495 and my brain says big number. Okay, so big number. We're going to subtract 360 because we want it to be something under 360. So when I look at the unit circle, I know where it is, right? I say 495, I don't know where that thing is. So, what is 495 minus 360? $135. I like 135. I can pick a quadrant out. Visualize with me. 135. It's past what? Before what? Past 90. Before 180. Which makes it in quadrant 2. Okay. 135 is in quadrant 2. Now, quadrant 2. Where is that closest to the x-axis? At 180 or 360? It's closest to 180, yes? So to find the reference angle, and again, you can look at your unit circle if you need to for help here. 135 is right there. I want to know how far it is from the x-axis. So I'm going to do 180 minus 135. And 180 minus 135 is 45 degrees. Did I get one of my 3 angles there that's on my chart? Yes. So now, we're going to be doing the cosecant of 45 degrees in quadrant 2. What do we know about cosecant? Okay. Opposite letter, right? So cosecant begins with C. What's the main one that begins with X? And this is sine. So we're doing the reciprocal of the sine of 45 degrees in quadrant 2. So, this is where my brain says, what's the sine of 45 degrees? Square root of 2 over 2 is what we tend to say. Knowing I'm getting ready to say what's the reciprocal, instead we're going to say 1 over square root of 2, right? So the sine of 45 is 1 over the square root of 2. The reciprocal of that is square root of 2. So the cosecant of 45 is square root of 2. Quadrant 2.
Positive.
All students. Begins with S. So sine is positive and its reciprocal is positive. So positive square root of 2. At least you guys have confidence on the angles, or on the degrees. We got to keep working on the radians. I'm not letting you off the hook. Okay? I can't.
I have a feeling radians are not like this.
Well, those of you in physics, do you guys talk radians at all, or do you only talk degrees?
We talk radians only because it's easier to calculate radians.
Okay, so you talk the radians there. Anybody that does anything with calculus, whether it be calculus in high school or calculus in college, you'll talk radians. Okay? Okay, guys. So we're going to keep working on those. You're going to see those in homework. You're going to have to work on them, okay? Now, all of the angles that we just did, they fell in one of the 4 quadrants, right? And so we could figure out what their reference angle was by how far away they were from the x-axis. Okay. Now, situation here is, okay, what if it falls not in a quadrant, but on an axis? Okay, so we're going to be looking at some special cases. You guys remember when I drew Jace's phantom triangle last week? Okay. How do we do that without having to draw phantom triangles? Okay, that's what we're going to look at here. So, angles whose terminal sides lie along one of the quadrant axes were called quadrantal angles. So when it lies on an x or y axis, it's a quadrantal angle. These do not produce a reference angle, so we have to have a special way of finding them based on the unit circle. Now, in an ordered pair on the unit circle, so if we are on the unit circle, and so we're using these numbers here, where unit circle where the radius is 1, notice what it says here. The x value is the cosine value. The y value is the sine value. And all other trigonometric functions can be found based on those. Okay, guys, some of you asked me, I don't know if it's this class or my other class, but on the unit circle I provided you, I have cosine and sine written on there, yes? And somebody asked me why, and I said, just hold on. We'll get there eventually, okay? We're here. I just said the cosine is the x value, right? So right here, notice I have cosine written alongside the x-axis. Your y value is your sine value. Okay? Now, as you look at ordered pairs here, if you go on the x-axis, over here at 0 degrees, yes? If you're looking for an ordered pair there, that would be going right 1, up or down 0. And so what that means, right 1, up or down 0, at 0 degrees or 0 radians, the cosine value is the x value, which is 1, and the sine value is the y value, which is 0. So if I'm asking you what is the cosine of 0 degrees, your answer should be 1. If I ask you what is the cosine of 0 degrees, your answer should be 0. And you could check that on your calculator. Your calculator would provide those answers as well. Okay, so what if we go up to 90 degrees? That would be moving, think ordered pairwise, that would be moving left or right, 0, and up 1 if we're landing on the unit circle, right? So if we do that, left to right 0, up 1, the ordered pair, 0, 1. 0 is your what? It's your x, which is your cosine. So the cosine of 90 degrees is 0. What's 1?
Y.
It's your y, and y is the sine. And so the sine of 90 degrees is 1, the y value. Cosine is your x, sine is your y value. And in fact, if you want to write on your unit circle, this might be something that is helpful to write, that an ordered pair is cosine, comma, sine. You know, like that's your reminder that an ordered pair is cosine, comma, sine. Okay? Yes?
I don't know if I missed something on cosine there, because when you said the cosine of 1, did you say it was 0, or did you say it was 1 there too?
We haven't talked about the cosine of 1. We've talked about the cosine of 0 degrees and the cosine of 90 degrees. We won't talk about the cosine of 1. We talked about the cosine and sine of various degrees.
Okay. So the cosine of 0 is like 1.
Yes. No, the cosine of 0 degrees, it's the x value, which is
Oh, just 1.
1. And notice, there's ordered pairs all the way around the unit circle, yes? Over here at 180, the cosine of 180 is negative 1. The cosine of, the sine of 180 is 0. 270. Cosine of 270 is 0. Sine of 270, negative 1. Are you catching on? Technically, did you notice there's a lot of other ordered pairs around this unit circle?
Yeah, so it's right.
Those are all the cosine and sine values. Think about it, guys. So, on your chart, the cosine of 30 degrees, according to your reference chart that you're supposed to be memorizing. What's the cosine of 30 degrees? Square root of 3 over 2. Notice what's the x value right here? Square root of 3 over 2. What's the sine of 30 degrees? 1/2 according to my chart. What is it, the y value here? 1/2. Notice these x, y values are the same all the way around the circle, yes? They're repeated over and over and over. The difference is positive and negative signs. When you get over here to 150, the difference is you have to go left and then up. So my cosine is negative when you go left. My sine is positive. Well, isn't this a positive sine quadrant? All students. Notice my y values, my sine values are positive. Okay. Down here, this is my cosine quadrant. Notice all of my x values are positive. Down here, this is my tangent quadrant. Notice cosine and sine are both negative because it's my tangent quadrant. Okay? So other ways you can use this unit circle. There's lots of ways to use it. Now, so this is what we were just talking about right here. Off to the right, notice, and I already wrote it on my circle, in an ordered pair, x, y. So it's cosine, sine. The sine is the y value, the cosine is the x value, and here's something helpful to know. What's the tangent? Y over x. Okay? So it's always the y value divided by the x value, which, if you think down here in this quadrant, when y and x were both negative, a negative divided by a negative is going to be a positive. Okay, so in this section, all of these land on axes, x or y. You just have to figure out where it is and then go from there. So sine of negative 270. Yep. And I'm going to do a tiny sketch over here just for a visual. Let me get it zoomed in so you guys can see appropriately. The sine of negative 270. Well, if you can visualize negative, going down, right? Negative 90, negative 180, negative 270. So it ends up being the same as what? 90. If you're not a visual and you'd rather add and subtract, what do you do with negative 270? You take negative 270 and add 360. And so if I do negative 270 and I add 360, guess what? I am at 90. So when we say the sine of negative 270, it's the sine of 90 degrees. What is the ordered pair that represents 90 degrees?
0.
Left or right, 0. Up, 1. Of 0, 1, which is my sine value.
1.
The y value, which is 1. So the sine of 90 degrees is 1. And since 90 is the same thing as negative 270, the sine of negative 270 is 1. Questions on that? Now, this would have been a lot easier at the time instead of having to draw phantom triangles, yes? But, you know, it all comes. It's pieces. It's gradual baby steps here. We put it all together. Okay, you ready for me to try another one then? Okay. Tangent of 3 pi. Three pi is big, yes? So if it's too big, what do? Subtract off 2 pi from it. What is 3 pi minus 2 pi? Pi. Oh, do we know where pi is? So what we're really doing here is the tangent of pi. Now, where is pi? It's the same place as what? 180. And this is the place where we're not really converting it, but, you know, equivalent. Okay, pi is the same as 180. So pi is at 180. What is the ordered pair for pi or 180? You go left 1, up or down 0. So if my ordered pair is negative 1, 0, we want the tangent. Tangent, according to my little cloud off to the right, is y divided by x. Y is 0. X is negative 1. 0 divided by anything is 0. Okay. Continuing along. Secant of 11 pi over 2. My response, 11 pi over 2 is, I'm going to say, big. And when I say big, all I'm saying is that it's bigger than 360 or bigger than 2 pi. Okay? So, if 11 pi over 2 is big, what do I do to make it smaller? Subtract how much? 2 pi. Okay. What is 2 pi if I want a denominator of 2? 4 halves, right? 4 divided by 2, 4 halves is 2. So 4 pi over 2 is what I'm subtracting. 11 halves minus 4 halves. 7 halves?